Hello everyone, welcome back to Mindmatrix. So today we will be starting with machine learning, the most awaited topic, most exciting topic of GATE data science exam. And if I talk about in general, yeah, this is the hot topic today in the market as well. So we'll be starting with this topic today, and yeah, so let's just start, and I'll be delivering some extra stuff, which I'll be talking about as we proceed further. So here is the quick intro about myself. For the people who have not been following my probability playlist, I'm upcoming data scientist at Lowe's India. I'm finally a student at IISc Bangalore pursuing M.Tech AI. And I already have 3+ years of experience in gate industry, and yeah, rest you can see. Okay. And yeah, these 200K views, if I talk about, so these are on the different platform combining over where I have already worked at different platforms. So yeah, that was all about me, and then let's just proceed further with the actual syllabus of the GATE data science and AI exam. So if I just talk about this thing, so one important point you would get to know that the topic, if I talk about the syllabus, it is actually starting with supervised learning. But to be honest, before jumping onto that, there is big prerequisite you must follow. Then only you can understand this thing. Okay, any topic basically. To understand that, you need good foundational knowledge. So I'll be focusing upon that first. And if I talk about before GATE 2024 exam, what I'll be covering, because like there is already very less time left. So what I'll be focusing upon is first of all, I'll build up the basics required. I'll build up the basics required, first thing. The second thing would be I'll provide you the enough of what should I say, the terminologies which are related, because there are too many related terminologies which you must know. Then only you can proceed further. Okay. So the order would be I'll cover the basics, then terminologies, and then I'll be talking about these two important things because they are easy and important. Because these are easy and important to understand for the from the exam point of view. So bias variance trade-off, I'll pick up cross validation method completely up to this point. Okay, and then this thing, one machine learning technique which I'll be taking, because there are a number of others as well, but I would be able to cover one only. A reason being, we have already discussed its basic, because for others we may be needing some different kind of concepts. For an example, for linear regression, you would be needing a linear algebra, a bit of it. Okay, and for logistic regression as well, like you would be needing some good background. So just overall, after looking at it, I got to know that okay, if I had to cover only one topic, so it must be naive based classifier which I can do. Okay, because when I'll complete it, it would be already like too late within January. So I don't want you to be struggling much with the syllabus. Okay, whatever we cover, we'll cover it properly so that if any question arrives, you would be able to tackle it, handle it, and able to solve it. Okay, so let's proceed further. So this is the agenda for today's session. So I'll be talking about the definition, what exactly is ML. Then we'll talk about this misconception, because most of the people feel ML, data science, and AI is nearly same. And yes, to be honest, like most of the companies, when they come for the profiles, say they are looking for data scientists, but some kind of ML work is they have to do, and sometimes it's like ML people. So like these are interrelated, but there is a fine line, and we have to understand that. So I'll be telling you that. Okay, though for AI is very different from ML and data science, but yeah, there is a fine line between ML and data science, which we'll discuss. And if I talk about the types of learning, then we are going into the ML now. So I'll be talking about supervised, unsupervised, and reinforcement learning, and then uh, followed by important jargons, the terms which are important over here. Okay, so we'll be talking about that. So if I just talk about the important definition, what exactly is our this machine learning? So this is the reference I have used. So this is from Wikipedia. This is from the IBM's website, and this is not the definition, to be honest. This is something which I found on MIT's management schools page. Okay, so there I have found it, and it had a crux basically. what is, what all you can say machine learning. So it has that. So just to give you a good idea about that, so I have included this as well. Okay, so let's just read the last one first. Okay, machine learning is behind chatbots. So wherever there are chatbots, it is being used. Predictive text, language translation apps, Netflix shows they are recommending you. So yeah, over there also, and social media feeds you are getting, autonomous vehicles, and machines that can diagnose medical conditions based on images. So like there are cancer detection, tumor detection, all these things are already going on. So machine learning is a vast field. The application is, you just tell me a field, it will have an application there. In today's time, this is the scenario. So that's why it becomes very important for one to, equip him or herself with this kind of domain, so that at least they must be having a good idea, basic idea, so that further if they need it, they can explore further. Okay, and over here this image is taken. Okay, so yeah, it's not created by us. So like over here there is an example that people often thinks, okay, that somebody is teaching machines, okay, to recognize, to identify, to learn. So that exactly is not like that. This is not machine learning is taking place. Like there is a great what should I say, mathematics behind it, which we will learn. Okay, so proceeding further, the above two definition or any definition in general, if I talk about any good place, wherever you refer this definition from, you'll find these kind of words. Basically, the subset of AI for sure. And the other thing is learning from data. Learning from data, or basically using data to learn or to imitate in a way that human can learn, something like this. So in both the definitions, they are using the same kind of stuff. Okay, I guess the definition are self-explanatory over here. Like field of study in AI concerned with development of study in statistical algorithms, which we will be discussing exactly that how these are statistical algorithms when we delve deep into it. And basically learning from data and generalized to unseen data. Generalized to unseen data means, so you'll be having data and machine will be training through that. But what if machine comes across a new data point, then will it be able to perform on it or not? Because for an example, like in a class you are being taught how to solve maths problem, but on the test day if you get some new problem, will you be able to solve that? So this is how we try to generalize generalize the problems over here. That can my machine learning algorithms generalize over unseen data or new kind of data it is seeing? Is it possible, or how does it perform if it's possible? Okay, so that is the point over here. So if I talk about the second one, again similar kind of definition, but one thing extra is that it learns from the data, uses the data to imitate the way humans learn, as human learns. Okay, and gradually improving its accuracy step by step, slowly and slowly, it increases its performance as well. Like any kid learning alphabets and then words, sentences, something like this. So this goes like what should I say, like it's a step by step gradual process, that even for the machine learning you will be training machine learning algorithm. You'll see that okay, initially its performance won't be good, and then slowly you'll see that okay, it is performing better, and then you'll be getting good accuracy later on. Okay, so that's how the algorithm would be learning from the data. So I hope a basic idea is clear. So like we are somewhere around. And if you ask me what exactly is machine learning, so I would prefer to say in simple words, which would be something like this. So it's like ability to automatically learn from the data and past experiences to perform, to identify patterns. First of all, we have the data. We'll be trying to figure out some kind of pattern within that. For an example, like there has been these kind of problems now. So one, two, so let's suppose four, and then let's suppose seven, and then let's suppose 11. Can you tell me the next number? Can you complete this series? If I just ask you. So there is a pattern hidden within this series, what I have written. So 1 plus 1 is 2. Okay. Then I'm adding a natural number every time to each number. I'm adding a natural number every time. So 1 plus 1 is 2 because I have done with 1. So let me just show you. Over here the difference is 1. Over here the difference is 2, 3 and 4. So I'm just adding a next natural number and then creating it. So there was a pattern hidden in it. Okay, if you just look at this series carefully and don't think much, you will see, okay, this is just a data. But when you go into this kind of data, you'll find some kind of pattern. Similarly, in every kind of data, be it a speech data, be it a textual data, be it a geographical data, be it image data, any kind of data, you will find a pattern for sure within it. Okay, that's how we can, produce such kind of good recommendations. That's how our, these social media, basically, if I talk about Facebook, Google, they know what to show us somewhere. Even if we have a biased view, so they'll be showing the content based on our views only. That's the reason, because they have identified the patterns, identified the scrolling patterns of us, that to which kind of content we devote more time. Okay, so to identify pattern and to perform required task with minimal human intervention. Now what can be the task can be as simple as identifying that, okay, is the image shown to me having a cat or a dog, something like this. Or simply, if I'm getting an email, should I be putting it into the spam folder or actual inbox folder? Okay, and some other kind of machine learning task can be like like learning how to drive. That is also part of that. Okay, self-driving cars I'm talking about. Then this is about social media post and recommendation systems. Okay, and this is about finding the pattern within the data. If you see, like, this is a kind of normal data we had. Normal doesn't mean the distribution I'm talking about. This is like the what should I say, okay, you have this kind of data available, you plotted it, and then you can relate. See, if you observe it carefully, you'll find these are somewhat related kind of thing, these are somewhat related, and these are somewhat related. So that's what we have created over here. So we group them all together on the basis of some similar kind of characteristic. So we find that pattern after studying the data, after analyzing the data. So that's what machine learning is all about. Okay, further, so understanding the data and then predicting, as I mentioned over here, that identifying the class, that okay, was that a cat or a dog? Is it a valid male or it's a spam? Similarly, we can have this kind of problem as well, where we need to predict the rate of something, where we need to predict the life cycle of a product. Something like this can be there. Okay, so we would be predicting something, we would be finding the patterns within the data, we would be some way learning something. Okay, learning from the past data. That is our machine learning. I hope the overall high level idea is clear. As we proceed further, we'll get the exact, clearly specific idea for each of the terms we talk about. Machine learning, data science, and AI. Okay, so let's just talk about further. Talk about these further. Okay, so if I just talk about this thing, so let me just create a Venn diagram to make you understand better. So AI is a big pool. Okay, this is like AI. AI is a big pool where number of technologies and tools are being used. Within that, there is a small portion called ML, machine learning. Okay, within that there is a small portion which we consider deep learning. And if I talk about the data science, so this is somewhat our data science. Now let me just tell you what can be different over here, how these things can be different. So just to tell you, so AI would simply mean, artificial intelligence would simply mean that our system are able to perform like human, that our systems can perform like human. So over here it can be like the simple robots doing the codes in the what in the factories. We have the factory line set up where robots are manufacturing and all that stuff, that kind of thing. So that can be part of AI. Apart from that, if I talk about one thing are those manufacturing robots, or you have seen these kind of thing. Okay, cleaning robots are there. In today's time there are these pet dogs. If you have seen, uh, robot dog are also coming nowadays. Within India they are getting sale. If you can find out, you can just explore the Amazon, you'll find it, robot dog. And what else I can say? Yes, knowledge based systems, knowledge based, or simply rule based systems. So you may have something like this, okay, like in earlier days when the algorithms were not directly there, but yeah, those were there, but still some kind of systems where we used to use these kind of logic. Okay, if this, then this, if a statement, and when we combine all of these kind together, we create a kind of intelligent decision making, which kind of replicate human intelligence. For an example, to tell whether a person is diseased or not. So for an example, if someone is having, let's suppose, typhoid or not, so there can be a number of symptoms we will discuss about. So a person can fill up the details that I have this symptom, this system, this system. Then on the basis of that, my system can tell whether you have the disease or not. So isn't it like a human doing the kind of evaluation that, okay, you are having, as if a doctor was sitting in front of you and then telling you, okay, you have the typhoid. So that is a kind of systems which are there in AI. So along with these kind of system, it was knowledge based. We have provided enough of knowledge to it. Okay, direct rule based system, that if this then that, if this, if this, if this, then we can follow. So something like this are also part of AI. But if I talk about ML, then comes what? Statistical modelings and algorithm. We'll discuss about that in details further. Okay, we'll be discussing that statistical modeling and algorithms. So over here, you are basically talking about some algorithms. Okay, some algorithms you talk about, and then talking about learning from the data. So over here, the data was being used as direct knowledge. It was used as direct knowledge. There was no such kind of thing present. Okay, that okay, on the basis of it, can I conclude something? It was composition of a number of parameters. But over here, I'm actually learning from the data exactly. Okay, so this is a kind of data, this is a kind of data. For an example, if I predict the rate of a house, so in that case I'm having n number of data points available with me, thousand or millions of data points which are telling me that within this area this house has this price, then this price, then this price, something like this. So then we are learning from the data using these algorithms, statistical modelings. So those comes and becomes the part of our machine learning. And often we talk about modeling over here. In ML we talk mostly about the modeling part, which is important. Okay, let me just write algorithm and modeling we mostly talk about. Okay, the finer idea we are getting. Deep learning is mostly about neural networks. Okay, we'll see each of these further. This is just to make a clear distinction that where does ML, machine learning, differs from deep learning. In fact, deep learning is also a kind of machine learning only, because you are learning from the data. But in deep learning you're using neural networks over there. Okay, and if I just talk about the data science is more related to data than these modeling and creating algorithms and all that. Because over here in data science you need domain knowledge to find out insights from data and create better informed decisions. What does it mean? So basically, within data science, you use data as in everything, like be it ML, DL, AI. This has some common intersection with this kind of thing. Okay, data science has that common intersection because we are using ML algorithms for sure, deep learning also. Okay, maybe simple rule-based stuff as well. But apart from that, there are some other things as well. We have some kind of domain to talk about over here. Okay, because if you don't have domain expertise, domain experience, you cannot create better informed decisions, because ultimately data science is more about analyzing the data and generating insights and create better decision. I hope the idea is clear. So other things which are part of this data science thing is visualization, creating dashboards, which are not the part of this deep learning or ML thing. Okay, visualization, dashboards, dashboards making, just to analyze all data at once. Visualization, dashboard, and EDA, exploratory data analysis, some kind of extra stuff, basic data related issues and data related process. So if I just talk more about it, what can also be there? So you must have heard about data engineering, data analysis, all these terms you must have heard. So data science earlier used to compose of these things as well. Now they have separated just because they have evolved to a much bigger domain. So data engineering was all about you know getting the data, getting the data. It was only related to getting data to a better form, converting data into a usable form. So that was in brief, in short, if I would like to tell. So that was about data engineering. So earlier, data science used to do this. Okay, they have to get the data, convert it into the proper form so that they can use, then analyzing the data. Okay, and then further, if you use machine learning and all that, then creating better informed decision by knowing, okay, what can lie in the future. ML is restricted to that, okay, this is going to be the prediction, that's it. Now what are you doing with that prediction? That is more related to data science. Okay, that how ML is telling you some answers, how you are using it for the business is all about data science. I hope you get this idea clearly. So ML is more about modeling and algorithms. Okay, the kind of designing systems, and data science is more about business, generating insights, something like that. And AI is a bigger umbrella over under which there are a number of things, and we have discussed about those things which are not part of ML as well, but are part of AI. I hope the idea is clear. Okay, so let's move further. I'll just talk about these things. So what exactly is a supervised learning? Okay, so we have seen this. Okay, so if I just talk about, so these kind of learning I'm going to talk about include data. Data would be the core of machine learning. Okay, so it depends on what kind of data, or how are we using that data. It depends on that. On the basis of that, we can have different types of learning algorithms. So if I talk about for supervised learning, basically the type of data we use is labeled data. What? We have labeled data. Now, what does it mean? It means that the data we are having, we already have a target variable. So let me just talk about a few terms over here. No, like I guess the next slide we are having. Yeah, so I can discuss it there. So we simply have a labeled data. So let me just in brief give you an example. So let's suppose we are here to predict the height of people. Okay, based on geographical area, geography, family background, basically like by knowing that, okay, what has been his family history, and then geography, family, what else we can consider. Okay, height. Okay, the past medical history of this person, medical history, and health right now. Basically it would be medical history only, but yeah, just for the sake of completeness, let me just take it, let me just consider it. Okay, so on the basis of this, I'm trying to predict a variable which is height of that person. Okay, he may be male or female. So what I'm talking about, the health, yeah, this may include the sports or daily routine kind of stuff. Okay, health and diet, yeah, this would be better. Health and diet, what kind of diet he's taking, then this is medical history, then his geographical area, and then this is the family background he's having. Okay, because family also, you know, somewhere affects that what can be your average height or what is the height you can obtain. Maybe there may be exceptional cases as well, but there is always a pattern which is being followed everywhere. Okay, that's the reason machine learning is so successful, because in our world as well there are so much patterns. If you know, analyze them carefully, you'll find something, some kind of, you know, relation in between the things. And that's why machine learning is so much in demand right now. So if I talk about the supervised learning, so you have the data points and you have some target variable always, okay, which you use and which you want to predict, which you want to find out. Okay, so what happens is you initially learn from the data that, okay, if this is the health or diet, if this is the medical history, geography, family, okay, this is the height possible. And then similarly you will be having, you know, number of data points available. You'll learn everything that, okay, for these kind of, you know, what should I say, features of a data point, I'll get this height. For this kind of data points, sorry, features of the data point, you'll get this height. Then you have learned something. And then when you get some new data point, for an example, okay, let's suppose you may be trying to predict, okay, that what must have been the height of a particular person based on his health, diet, medical history, geography, family, and then you get to know, okay, there is a height associated. You are getting that value. So then you are predicting that particular value. So that is a kind of supervised learning, when you predict a class or a value, predict a category or a value, predict a label or value. I hope the idea is clear. So over here in supervised learning, you basically have label data, as you have this kind of thing, basically the height present over here. And if I simply talk about when you will be having images, so the labels would be, is it a cat or a dog? Is it a cat or a dog? Simply because you'll be having this target always in supervised learning, that what target I am looking for. You will always be having that target, whether I want a class to find out or I'm having a value to find out. Okay, and then I'll be learning from the existing data to predict those target variables or category. Okay, now what is in unsupervised learning? You have unlabeled data. And to be honest, very honest, these target and all that, those are just misconception. In fact, if I just say that this is not the target, if I simply say that this is not the target, and I consider it to be simply a data, then it is my unlabeled data. Then this is my unlabeled data. To be honest, this becomes my unlabeled data, because I'm not have a goal variable to, you know, find out. In unlabeled data, you may be having, you know, every, as I mentioned in the supervised learning part, that you'll be having features for the data point. And you know, this target variable is also a kind of feature when it comes to unsupervised learning, because let's suppose the same data you are having, but you don't know what you have to do with this kind of data, then that label is nothing but another feature for your data in that case. Just an example for that again. So it's like you have complete data available for, let's suppose, Netflix data you are having, Netflix data. Okay, so over there you have that, okay, these people are watching these kind of movies and all that stuff. So now if I say that I'm having just, you know, this kind of data, just give me some kind of analysis or come up with something from this data. So in that case, what I'm looking for is a kind of unsupervised learning, because I don't have any target to produce. I'm not any target to predict. I'm just simply exploring the data and then coming up with the insight. But if with the same data, if I could have said that, okay, there is a category associated, if I say in advance, okay, there is a category associated, and if I have told you that, you know, these movies are nothing but following this category, then that category can become the target variable which I would like to use for further recommendation of the movies. That okay, this person likes more of action movies, romantic movies, then I would be, recommending those kind of movies. So we had a kind of unsupervised learning example over here. So this is this one. So for an example, you had a kind of data available with you. You don't know what exactly you are looking into it. Okay, you had just data, and then some insights needs to be generated from that. So what you are doing is you are trying to visualizing that, or maybe you may be reducing the dimension as well, because sometimes what happens is, as I mentioned over here, for an example, the dimension was 1, 2, 3, 4. If I just talk about the supervised part, so there was 4, and if I include this as well, so dimension was 5. So in actual data, there may be kind of thousands of features. The dimension can go up to the millions as well. So in that case, you won't be able to find out very good insights, to be honest. You have to reduce it to considerable amount of features, so that you can understand them better. Because if you are having thousands, then just forget it that you can do something very useful with that data. So sometimes what happens is you want to reduce the dimensionality as well when you have the data simply. So kind of dimensionality reduction. And what else, like yeah, I mentioned clustering. So that example which we had over here, this is a clustering example. I simply plotted the graph, and then I observed, see, all these were of same color. That means for me, when I was plotting, I was not knowing what exactly is there or not. I simply plotted, and then I got to know after observing, oh my god. So these are somewhat kind of, they are called together. So there is some kind of common traits, common properties, common characteristic they must be sharing. Similarly over here. So that's how I came up with something, okay, a kind of grouping, a clustering, that okay, this is one of the cluster, this is one of the cluster, this is one of the cluster, and each of these cluster are basically sharing some common property. So that was a kind of insight I learned from the data. That was again a type of unsupervised learning. I hope the idea is clear. So unsupervised learning is most of the time when we don't have a target variable. So basically I'm having unlabeled data, and then my goal is to find out some kind of to analyze that particular unlabeled data to get some insight from that. That is unsupervised learning. Now what is reinforcement learning? So reinforcement learning is all about learning by doing. That is reinforcement learning. Just for an example, you have a dog. If you have a dog or a cat, you have made them understand the commands, what to do on their commands. So you use a process for that. Okay, I don't know whether how many of you use the penalty, but for sure you would be using reward, a treat for the cat or a dog. That okay, sit. If they sit, you give them treat. Yes or no? If they don't sit, and if they don't listen to you for a long, you may be having a stick, just to scare them a bit, so that they get to know that okay, this is not good. That is the kind of penalty they are having. So whenever a learning is taking place with the help of interaction, with the help of rewards, gains, and penalizing or penalty, then it is a reinforcement learning. For an example, self-driving cars. Over there, they are learning, okay, that okay, what were the path I must not have taken, what is the actual path, what is the object needs to be, I must be care of. And similarly, if I talk about, you must have seen a robot learning to walk. There is a good visualization video on YouTube. You can check out that how a robot learns to walk. So he'll get to know each and every point where he can fall, and he would not be repeating the same thing further. Okay, so you learn that okay, by trying different things, and you get to know that this is the point, this is the step I must not be you know taking, this is the step I must not be taking, this is the step I must not be taking, because I failed, I got penalized, I got hit. So that's how you are learning within this reinforcement learning kind of thing. You must have played with computers as well. Okay, I don't know whether you know or not, whether you have played in real with that kind of within that kind of like environment or not. But there are some good games where when you are playing with the robot is actually learning to play. In the initial matches you may win, but later on that game or the computer is learning that which of my step led me to lose. Okay, so they then realize, okay, this is the step I must not be taking, this is the step I must not be taking, and they keep exploring, and then they find out what are the win-win situations. So that's how reinforcement learning works. So all in all, if I talk about, so there are these three major learning techniques we talk about. Further, there are others as well, which we should not delve into, but you can still, if you want to just look for that, you can just check out semi-supervised learning, and okay, the representation learning, okay, and self-supervised, semi-supervised, weekly supervised. So that these kind of other learnings are also there, which are just the further categorization, deep reinforcement learning, all that stuff. Okay, but right now it is not important because we are just starting. So these are the important three learnings I wanted to talk about. Okay, so let's move further. Let me just end this. I guess this would be the last. Yeah. So let me just talk about this a bit, and then we'll be seeing more terms in the next session. Okay, because important these jargons are very important to understand. So whenever we have a data, mostly I'll be talking about the labeled data. Mostly I'll be talking about the labeled data because most of the algorithm you're having, which you generally see or implement, would be supervised learning algorithms only. Okay, so you'll be having labeled data. So you'll always be having a target variable. You will always be having target variable, which is also called dependent variable. Target or dependent variable. Dependent variable. And then you'll be having some other variables which I can call as what, like dependent variables, sorry, independent variables, independent variables, or simply called features, okay, those are nothing but simply features. So just to give you an example, I have already taken, okay, so let me take that house wala example. Was it house or height? Okay, so let's suppose there is a health, then there is a diet related stuff. I'm not putting any values over here, I'll just talk about them later, that what kind of value we can have. Okay, health and diet, and then I guess the geographical area we talked about, and then we talked about the family, and then we also talked about medical history, med history, and then we had the target variable height. I hope you remember we took that case. Okay, so these are nothing but these are the features. These are the features, also called independent variables. These are also called independent variables. Okay, in general they may not be independent, to be honest. Okay, they may be dependent, but all in all, just when starting, we say that whatever features we are having, they are independent variables, and the goal variable, the target variable we are talking about, that is dependent variable. Because what ultimately we think is that, okay, independently these among themselves are leading to the value of this thing. So this value is dependent on these combined. So that's why we say this is dependent variable, and this is, all these are independent variables, or simply called features. I hope the idea is clear. Okay, so if I say that I have 100 data points, how many? 100 data points. So this would be something like a matrix, yes or no? This complete part, if I just talk about the x part, that means independent variables part. So this would be a kind of what? A kind of matrix. And if I have 100 data points, and you can see how many features I have, 1 2 3 4 5 5. Yeah, this is 1. Medical history is 1 complete. Okay. So we have 1, 2, 3, 4, 5. 5 features. Then what is going to be my dimension of X? X would be 100 cross 5 matrix. Is going to be 100 cross 5. Okay. And Y is going to be 100 cross 1. It is going to be a vector because there would be 100 data points. So I hope you know this idea of matrices. Okay. So if I have m rows, n columns, I write it as m cross n matrix. Okay. So y would be 100 cross 1 because there is only one variable I'm talking about. So y will be a vector. Vector is something like you can consider it to be a 1D matrix if you want, either m is equal to 1 or n is equal to 1. If that is so, then you have a vector. Just to understand in basic, easy language. Okay. So this is the kind of dimensionality you are having. Okay. Now let me just talk about this thing. Okay. Let's suppose you are talking about which we will be, should I get into it or not? Let's just address that as well. So if I say x1, x2, then I'm talking about first data point. When I'm talking about x2, that is second data point. Okay, that means row I'm talking about. Row, first row, second row. And when I say, this is the notation which we will be using. If I say, let's suppose x5 and over here I'm writing something like 3, then I'm talking about third feature of fifth row, or simply this is the column. This is column I'm talking about. This is row I'm talking about. Okay, in simple terms right now. I hope this idea is clear. So I have understood how data we are having. So data would always be like this. If I'm talking about supervised learning, it would always be in the form we will be having some x and y. Okay, x represents this complete matrix, y represents this complete vector. Okay, so I hope the idea is clear that how my data would be present. Okay, now within these I have talked about independent variable, dependent variable. The other thing is these independent variables are nothing but these are also called features. Okay, now I hope up to this idea is clear what exactly is the feature, what exactly is the data. So I'll just remove this all and we'll just talk about the next part, and then yeah, we'll end this soon. So I'll just erase it up, erase these everything. Okay, so now depending upon type of values we can have what, categorical features and numerical features. Numerical features means you are having some numerical value. Okay, you are having some numerical value like 1, 2, 3, minus 5.6, 7.8, 103, something like this, 7, minus 7, 6, 8, something like this, or 4, 3.98, something like this. So these are all like numerical values. So if any feature are having numerical values like this, those are called numerical feature. And if the feature are having values like, okay, let's suppose for an example, the example of categorical features can be gender, male or female, color, okay, gender, color, or any kind of category you are having, any kind of categorization. For an example, let me just write, yeah, basically we are talking about categories. So we don't have a kind of, numerical values present over here. Just to understand on a basic level. Okay. Gender, color, type of product, pet type of product. So it can be electrical. Okay. So like within that there can be further category, grooming category and all that stuff. So type of product or pet. So basically, are you talking about a cat or a dog or a squirrel or a rabbit or a snake? What type of, pet you are talking about? So depending upon that, like, what type of features you are having, you'll be having categorical features or numerical features. Similarly, when you have your target variable, if that is categorical, that means if you are predicting a kind of category, then your supervised learning problem becomes a classification problem, a kind of classification problem. And if you are predicting a numerical value, then that becomes a regression problem. What do I mean by that? So for an example, you have understood what exactly is a categorical feature or what exactly is a numerical feature. And that indirectly represent or directly represents the type of value which are being used under that feature. So if my target variable, which was dependent variable, you remember we were talking about supervised learning only. So if my label or the target variable is a kind of category, then the problem I'm having is a classification. I have to classify my data point into this category or this category or this category or this category, something like this. Or if my target variable is a kind of value I'm trying to predict, then there is no category that okay, it must be one or two or three. No, there has to be a particular value it must be predicting. For an example, when you're predicting the price of house, okay, for an example, when you are predicting the lifetime of a product, something like that, okay. So most of the time we'll be having this yeah, one more thing can be, for an example, you are predicting the engagement of a user. You are watching this video on the YouTube. So if I have a YouTube data, I can predict something like, if I have the video data, I can predict what will be the average duration of that particular video. So that is going to be a numerical value. So then it becomes a regression problem. Okay, I hope that is clear. Classification is basically classification and regression problem. Both are a kind of supervised learning problem. Okay, and when you have a category or a class to predict or a label to predict, then it's a classification problem because you are categorizing either this kind of data point would be of this category or this category or this category. So it's a kind of classification problem. And when your target variable is actually a value you would like to predict, okay, that for this kind of feature I can have this rate, this price, this much of lifetime, this much of average duration, average view duration I can have, then it's a regression problem. Okay, I hope the idea is clear. What is classification problem, what is regression problem, what are features, what are dependent variable, what are independent variable, categorical features, numerical features, okay, and how we are having this kind of data means how do we define the data. I hope all of these are clear. If you have learned, and if you have enjoyed this session, kindly give a thumbs up to this video and do share it with your friends. Comment down how was this video, because this is it what I wanted to cover within this particular video. And in the next video I'll be talking about more jargons, because those are important before delving deep into the machine learning world. Okay, so that was all about today's session. I hope you have got a good sense, good idea about whatever we have covered.